Hello math lovers, welcome to the channel. We have a geometry question in this video. The question goes like this. A hemispherical oil tank is lying with its base surface on the ground. A ladder L1 is leaning tangentially upon the tank with its foot F on the ground. The point of contact of L1 with the tank is P and the distance FP is 4 meters. The shortest distance from F to the tank's surface is 2/3 of the tank's radius. Then we have got two questions. The first question is find the curved surface area of the hemispherical tank, and the second is there is some information. If another ladder L2 of the length 2 times the square root of 91 meters is leaning tangentially on the tank with its foot on the ground twice as distant from the center of the hemisphere as F, then what is the vertical height of the top end of L2 above the ground? So friends, let me explain you the question. So we have got this hemisphere. This is an oil tank. So its base is lying on the ground and only the hemisphere is appearing on the top. So we have a ladder. This ladder is L1. So this ladder L1 is lying tangentially upon this oil tank. So lying tangentially means that there is only one point of contact between this ladder and the hemisphere, and that point of contact is P. So this ladder has foot F on the ground and the length from F to the point of contact P is given 4 meters. You can see O is the center of this hemisphere. So from O to M, this is a radius. So the distance of this radius MO can be represented by R, and then it is given that the shortest distance from F to the tank surface is 2/3 of the tank's radius. That means this much part, M is the shortest distance from F, and M is on the surface of this hemisphere. So this distance is given 2/3 of the radius, that is R. Now we are to find out the curved surface area of this hemispherical tank. And in the second option there is some information that there is another ladder L2. This is L2. So the length of this ladder is 2 times square root of 91 meters, and it is also leaning tangentially on the tank with its foot on the ground. So its foot is A. So it is also lying tangentially, means there is only one point of contact between this hemisphere and this ladder, and that point of contact is N. Then it says that its foot is twice as distant from the center of the hemisphere as F. That means if FO is 1, then AO is 2. Now based on this information, there is a question that we have to find out this vertical distance from the top end of L2, that is B. So we have to find out the length of BC. So let's find out. So friends, before I start the answer, there is a theorem based on which the question can be answered. So the theorem goes like this. The tangent at any point of a circle is perpendicular to the radius through the point. So this means that if there is a circle and if there is a line, and when they come in contact, so there is only one point at which they touch each other. So in this case, if you take this line L1 and if you take a hemisphere, then there is only one point of contact between this ladder and this hemisphere, that is P, and the radius which passes through this point of contact to the center is always perpendicular to this tangent. So you have to keep this theorem in mind. So now let's go to our question number 1, that is we are going to find out the curved surface area of this hemisphere. Consider this triangle FPO. So since this radius is perpendicular to this tangent, so this is a right angle triangle. So if this is a right angle triangle, then we can bring Pythagoras theorem in. So the Pythagoras theorem says that a square plus b square equals to c square, where c is the hypotenuse. So here also FO is the hypotenuse. So FO square will be equal to FP square plus PO square. So FO is this radius R plus 2/3 of R square equals to, so FP is already given 4, so it is 4 square, and PO is also a radius, so r square. Now if we add these two parts, then we get 5/3 of r. So this length FO is 5/3 of r. We square it. So upon simplifying this, we get that r is 3 meters. Now we are to find out the curved surface area. So friends, if we have a sphere, then the curved surface area will be 4 pi r square. If we have a hemisphere with base and we need to find out the surface area of the full hemisphere, then it is 3 pi r square. That means base plus the curved surface area, but here they are asking only the curved surface area. That means without base. So the formula is 2 pi r square. So we can place 9 in place of r square because r is 3, so 3 into 3 is 9. So we get that the curved surface area of this hemisphere is 56.57 meters square approximately. So we now move to question number 2. So in question number 2, there is some information which I have already explained it to you. I hope you remember. And there is another ladder L2 which you can see here. The foot of this ladder is A and the top end of this ladder is B, which you can clearly see in the diagram. So the length of this ladder is 2 times 91 square root meters. Now this ladder is also tangentially leaning towards this hemisphere at the point of contact N, and it is given that the foot of this ladder A is twice as distant from the center of the hemisphere as F. That means if FO is 1, then AO should be 2. Now we need to find out the vertical height of the top end of L2 above the ground. That means we are to find out the length of BC. So that is our vertical height of this ladder L2. Now we are going to use the same theorem here also. That is, our ladder L2 is a tangent to this hemisphere. So the point of contact N is the point where they touch each other, and from N we have a radius NO. So this NO is perpendicular to AB as per our theorem. So we have a triangle ANO. It is right angled at N. So now we can use the Pythagoras theorem, that is AO square equals to AN square plus NO square. But before that we have to find out the length of AO. So as I've already told you that AO is 2 times FO. And what is FO? FO we have already seen here in the first question. FO was 5/3 of R. So we can put 5/3 of R in place of FO. So AO will be 2 times 5/3 of R, and R we have already found out 3 meters. So by simplifying this we can get 10 meters. Now we can put this 10 meters in place of AO here. So it is 10 square equals to AN square. So AN is what we are going to find out, and NO. So NO is the radius. So NO is 3. So it is 3 square. Now after simplifying we get AN equals to 91 square root meters. Now you are requested to focus on this triangle ANO and this bigger triangle ABC. So these two triangles are similar. Why they are similar? Because both triangles are right angled. So the smaller triangle is right angled at N and the bigger triangle is right angled at C. And they have a common angle. In a right angle triangle, if one of the angles are common, and then the next angle will also be equal. So in these two triangles they are common and they are equal. So this angle corresponding to this angle should be equal. Now it is proved that both these triangles are similar, so we can use the ratio rule. Now let's use ratio. So from this bigger triangle we can use AB. This is the hypotenuse of this bigger triangle, and the hypotenuse of this smaller triangle is AO. So we can use AB or AO. That will be equal to BC of the bigger triangle, and BC corresponds to ON of this smaller triangle. So BC over ON. Now AB is given 2 times 91 square root. So we place it here, AO we have found out as 10 meters, so we can put 10 here, equals to BC is what we need to find out, and ON is the radius, that is 3. So by cross multiplication we get 10 times BC equals to 3 into 2 times 91 square root. If we simplify this, we get BC approximately equal to 5.72 meters. So BC is 5.72 meters approx, and BC is the height, and the question was to find out the height. So the vertical height of the top end of L2 above the ground is 5.72 meters approx, and that is our answer. And friends, do not forget to subscribe, and if you like the video you can press that like button. Thank you.